It's an absolute honor to be here today after 5 years of working together as a consortium. Um, and we've had such a great collaboration over the past years, and I'm really happy to be able to share some of the research on what we found in Aurora. So when we think about micro nanoplastics, we have to think about what pathways of exposure are relevant for all of us, but then in particular, what pathways are relevant during pregnancy. Micro nanoplastics are particles smaller than 5 millimeters in size and nanoparticles smaller than 1 micrometer. And these plastics can be intentionally produced to be used in consumer products, or they can be degraded from the plastics that we use in our everyday lives. And when these plastics break down in the environment, we can inhale them in the air that we breathe, and they can also be transferred into the food that we eat, and we can be exposed to them that way. So during pregnancy, the mother is exposed through both inhalation and ingestion to microplastics, possibly also to dermal contact. And then there's the potential for this to transfer through the placenta to the fetus. And Lawrence will be talking more about that later on. Now, the home represents a very important location for exposure. Adults and children as well spend up to 90% of their time indoors, and much of that time is spent at home. We don't know very much about the documented micronanoplastic home environment. Before we started the study, there were a limited number of homes that had been measured for micronanoplastic concentrations, but we can think a lot about what plastics we're using in the home. Things like the textiles that we have in our homes, they can be made from things like polypropylene or polyamide or polyester. And yeah, when we have these products in the home, our behavior can also interact with these products and lead to possible exposures. In order to answer some questions about exposure to micronanoplastics, we started the AURORA Household Plastic Study. We included 108 women of reproductive age in our study, all living within 50 kilometers of Utrecht. And in our study, we wanted to get a better idea of the internal exposure to micronanoplastics, as well as the external exposure to micronanoplastics for these participants, and also how these things change over time. We were able to collect blood and urine samples from all of our participants, and we did this using plastic-free collection methods. So our blood samples were collected in glass vials, our urine samples collected in glass jars, and we also collected the dust using a glass petri dish. We had our participants fill in a questionnaire where we tried to gather as much information as possible about what could be relevant for their exposure levels. This study started in the summer of 2023 and ran for 9 months until the winter of 2024. And we visited all of the households twice with a follow-up period of 3 months in between these visits to collect all of this information. In our questionnaire, I'm going to talk a little bit more about the questions that we asked in it. So this included things like sociodemographic information. We asked information about their age, how many people were living in their home, what the size of their home was. We collected more information about the characteristics of their home, what types of textiles that they had. We also asked questions about their lifestyle and behavior, if they used a dryer to dry their clothes, if they hung their clothes out in the living room, how often they opened their windows, and how often they vacuum cleaned. We recorded the characteristics of the sample collection, how high the sample was placed, when it was collected. And then we also used their home address to geolink environmental characteristics, things like urbanicity and air pollutants, which we thought might be relevant for the levels of micronanoplastics in the home. And another thing we captured was their diet. We asked about the different foods that they were consuming, the type of food packaging it was coming in, how frequently they were microwaving their food in a plastic container, and these types of questions. Now, for the rest of the presentation, I'm going to focus on the dust samples that we collected. As Rule mentioned, the biological samples are more challenging to measure, and we have a good idea now of what is in the dust in their homes. So we collected a sample over a 30-day period and a height designed to represent the breathing zone so that it reflects the exposure that someone might experience through inhalation. The micronanoplastics were measured with pyrolysis, gas chromatography, mass spectrometry, and that gives us a mass of how much micronanoplastic fell on our glass petri dish over that 30-day period we were collecting. When we analyzed these samples, our partner Barbara in Oldenburg, she took extensive measures to prevent contamination of the samples. And we also had field blanks and procedural blanks, which followed the same process as our study samples, so we could track any contamination that might have occurred. We targeted these 9 different plastic polymers as well as tire wear particles. And now we're going to look at the results of what we found in that dust. So I think that the most important finding here is that we found micronanoplastics in the dust from all 105 households that we measured from in all of the samples at both visits. And when you look at this pie chart that shows the contribution of each polymer to the total deposition, and the green slice is PET or polyester, and that represented 80% of the total deposition. So that really stood out to us in terms of being an important exposure within the home. We also measured polystyrene in almost all of the homes, polypropylene in 80%, and the other polymers, PMMA, polycarbonate, polyethylene, and polyamide in between 30 and 60% of the homes. But all of those polymers together only represented 20% of the total deposition that we saw. We did not see any evidence of tire wear particles in these samples, and we also didn't find any polyurethane here. And now when we look at the determinants and sources of the micronanoplastics in dust, you're going to see that table come back, and we're going to go through what we saw. And the key here is that a star means that a factor was associated with multiple polymers, so we have more evidence that it's irrelevant to contribution toward the levels, and a check mark that it's only with one polymer, and the red X is that it wasn't associated with any polymer. So we did see that age was a relevant factor, where the women who were a bit older, they tended to have a trend of having less polyester in their homes. Household type was very important. So the multi-person homes tended to have more micronanoplastics than the homes where there was only one person living. And that also is reflected in occupancy density. When there was more space per person, we saw less micronanoplastics as they were more spread out in the home. In terms of the home characteristics, we did see that having curtains in their living room was associated with one of the plastic polymers. Using a dryer had a trend of being associated with lower micronanoplastics in the home. And we saw associations with vacuum cleaning, but it wasn't what we expected. We expected that vacuum cleaning would be associated with lower levels for removing micronanoplastics in the dust. But actually, due to some redistribution of the polymers, we ended up with higher levels just for one polymer. The height of where we placed the dust collection was important, and we saw relatively limited contribution of the environmental characteristics. Our repeat samples indicated relatively stable patterns within the homes over time. And these questionnaires that we collected and looked for the associations with the micronanoplastic explained about between 23 and 46% of the variation between the homes. With this stability over time within a household, we think that household dust may represent a useful matrix to quantify exposure for epidemiological studies. And to wrap up, I just want you all to take home today that household exposure to micronanoplastics is widespread, with most of it coming from polyester. Our questionnaires only captured part of the micronanoplastic exposure variance, which means that taking direct measurements within the home is important. And yeah, the way forward is that our indoor environments represent important and potentially modifiable sources of exposure. So there are things that we can do to change the levels within our home. And to close, I just wanted to say thank you to our study participants who were very enthusiastic about participating in the project and wanted to know about their exposure, as well as the study team who put this all together. Thank you.